The first step was in the making of the mold. We first circular saw the pieces to the correct length. Next, we sand them to have tight fits and to avoid splinters. We then put the wood together to form boxes using 3.5-inch long screws. As shown in this angle, the wood that was cut was warped. To avoid the box from being at an angle, we took the wood and cut it at an angle. Therefore, the box was straight on with the other box. The top box of the mold is the cope, the bottom box is the drag, and the parting line separates the two. These are where the two come together. To avoid the cope and the drag from separating, when casting, there are 4 screws, each at one corner. The screw goes through the cope into the drag to hold the two together on all 4 corners. To avoid spending a lot on casting sand, we made our own casting sand. First, you need a couple of buckets. Second, you need a bag of play sand, which will go inside of the buckets. And third, you need a bag of kitty litter, and make sure that clay is an ingredient in this kitty litter. Fourth, a fine sift for making the sand and the kitty litter fine, a scooper for the sand and the kitty litter, a blender for chopping up the kitty litter into fine bits, and a spray bottle for wetting the kitty litter and sand mixture. For the making of the casting sand, you're first going to want to sift the sand into the buckets that you have. Next, you're going to hook up a cheap blender. We just bought like a $10 blender for this, and it actually died on us during this process, but it was enough to get about a 10% weight ratio of kitty litter to sand, which you add into the bucket, mix up the two, and you add a little bit of water at the end, and this makes for a pretty good casting sand. We then 3D printed the dagger to get exact dimensions in the mold. And here's how the 3D print turned out. All engineering projects have some failure. It just so happened that we failed for 6 hours. To attempt to melt the aluminum, we grabbed a grill and used coals. We lit the coals with lighter fluid, using leaves and sticks as tinder. We then placed the crucible containing the aluminum in the grill and surrounded the crucible with the hot coals. To get the grill even hotter, we blew hot air through a hairdryer. For safety measures, we wore masks the whole time and used thermal-resistant gloves when dealing with the fire. Although the fire was measured well above 1,000 degrees, we still could not get the aluminum to melt. Therefore, we needed to rethink and construct a furnace. We were, however, able to get the mold ready in time so that when we constructed the furnace, all we had to do was pour the melted aluminum into the mold. Next, we will consider the making of the metal foundry. First, you need a bag of play sand to mix with a bag of plaster of Paris. You will use a pitcher to pour water into the mixture and stir the two. A steel pail will serve as the base of the metal foundry, and a steel lid will sit on top of the steel pail, and this will keep the heat in. Next, you're going to need a plastic bucket, and this can be used as the base for the crucible to sit in. The crucible will hold the spare aluminum, and the charcoal will serve as the fire starter. You will first pour the mixture into the steel pail. You will then use the plastic bucket to create the hole for the base of the crucible. Next, you will wait about 1.5 hours for the mixture to completely dry. And here's how it turned out. As shown in the picture, we connected a steel pipe to the side of the bucket and blew compressed air through the pipe to bring heat to the coals. I will now let the visuals take you the rest of the way.